G'day viewers, I made a little mount for this motor. Sits on there. Now I can spin it up to the silly speeds. I don't think it's going to be fast enough to pop a CD though, so I'll just have some alternative uses for it if I can't pop a CD with it. Might need to take this one outside. This could get messy, this experiment. I'll just get set up and we'll see how we go. If I can do anything. Let's see if we can get some sweeping done, shall we? Too lazy to get the broom and do it myself, so let's see how this little sweeping machine goes here. I know I might be swept away with the results. I might not be, but let's see. Beatermix 0, power on. Oops. Come on, Ryder, you can do it. Nothing. Okay, viewers, well, this thing just has not got any bloody torque. It's pants. It's so pants, it's just nothing. So I'm going to have to put it in some water. And it's going to be death by float voltages. Alright. Let's see if I get the thing out of this. Hopefully I haven't hit the dead spot. We've got a multimeter in the water, and active, and a microwave oven fan there. If there's any current, enough lethal current in a circuit, that fan should go. Even the slightest bit of movement. Yep, look at that. Float voltages are lethal, people. There you go. Don't mess with float voltages. Dangerous stuff. Unplug safety first, circuit isolated, physical break. Be very, very, very careful when doing these sorts of experiments, especially applied with electricity and water. Take caution of fire risks too. Now, the most important thing when you're doing this sort of experiment at all, to make it even possible, without tripping the RCD of course, an isolation transformer. Alright, everything's disconnected. Let's reconnect. Reset the experiment. Oh, let's reset the experiment. The bloody lead's shorted out in there. The motor jumped and shorted the lead to alligator clips together. Can 0, power on. Reset the experiment. 55 volts in the water, between the water and the multimeter. And the Variax on 110 volts. Fan starting to go, that's just running on float voltages. The current through the water is enough to run that fan. So there's enough in there to kill you. My black lead's my anode there. There's enough current in there to kill, so. Now that's what I call float voltage. 78 volts, multimeter's measuring through the water. .28 volts, flat out, flan's going flat neck. Still no burnout. Alright, power off, unplug safety first, too wet, getting a bit dangerous now, that could start a fire. That cog was caught, gear on that thing was going to cut a hole through the bottom of that container, so. The water's a bit black and that's not the brushed material, so. Unplug safety first, a must. Be very, very careful when doing these things. Alright, I'm going to pop this motor now, bugger it, let it pop, let's finish it off. It's going to rust out anyway by the time I use it next time, so let's finish it off. Too wet to have this thing unisolated, so leave it isolated because there's water around. Safety first, have safety in mind when doing these sorts of experiments. Okay, Variax on 0, let's see if it still works. I've hit that dead spot, so 3, 2, 1. Yeah, these are dry. Haha, that's a failure. Yep. It did, Jim. It's dead. It's still a sizzler because I've still got the power on. You can hear there's a bit of electrolysis action going there. Alright, variac on 0. I'm not pulling any current either. Alright, variac on 0. Unplug safety first. Let's see if I can hit another spot, or if I totally popped it this time. Okay, let's see if there's anything left. I think it's been brushed to death. Yep. Totally open circuit. No activity from the ballast at all. All dead. I'll turn that down to 0. Power off. Unplug safety first. Let's tear that thing down. I managed to reconnect the brushes. The springs just came melted and came off, so I refixed those. Higher voltages, and now to get rid of this other colour bad contacts. There we go, arc motor. Yeah, brushes, who needs it? This isn't an electrical arc. Nothing will wear out then. Yeah, sparky fireworks. Fun beam, not sunbeam, it's a fun beam motor. Oh, my little board. Damn it. Unplug safety first. My little, got 20 amps of ballast, or a 10 amp breaker. Yeah. Should have known that wasn't going to last very long. Alright, now we'll try again. Not much current, so it's going to take a while to spin up again. There we go. It's a brushless hybrid motor. The arc is a brush. So there's no possible way anything's going to wear out. Come on. Pulling 16 amps. 20 amps of ballast. Variac's still happy. Yeah, Variac's still cold. Turn that down. Unplug safety first, very important. Let's give it a little twist. The primary of the MOT is a little bit warm. It's not hot, but it's getting there. Power on. Nothing. Oh yeah. Wrong power out there. Duh. My board's not even plugged in. I plugged into that. Alright, let's try again. Yeah, it's got a dead spot on it. Half the com bar's blown off. And this is pulling 15 amps. The reason why it wasn't burning out underwater before, because the water was acting as a coolant, cooling it down. Chicken stick. Dead spot. Man, it just doesn't want to die. I need more current, but the brush holders will give away because they're plastic. Alright, power off, Variac turned down. I'm starting to smell varnish from mott grindings. Yeah, a bit of smoky. Yeah, these things do not last long at all. Yeah, I won't pop this one. Unplug safety first. Yeah, it doesn't want to do it no more. Yep, it's got that smell of that first stage of burning. That's enough for that one. I think this one's pretty much buggered. Also, the secondary of this mott is also hot as well. Both the linings are overheating. There you go, the nearly got so hot it became shot. Anyway, that'll be enough. I'm amazed it still works at all though. Well, viewers, I think that'll be enough for now. I might have to continue this one another day. Thanks for watching.